This worksheet is all about balancing equations. With balancing equation, it takes practice and thus finding patterns. So I believe there's 4 practice problem here, but to be an expert at balancing, I advise you guys to go into textbook and do more practice problem on balancing equations. So here in this video, I'm just gonna teach you my tips and tricks in balancing equations. So first part is look at the more complicated atom. What do I mean by that? Is by looking at the subscript number of the atom. So do you see how iron, Fe, only has a subscript on 1, but Cl, chloride, has 2 and 3. That means I'm going to balance those complicated one first. So if I balance the complicated one first, Cl2 and Cl3, to balance this out, I know their common factor, right? Common factor is 6. Lowest common factor, right? So I'm going to times 3 here and 2 here, giving us Cl as 6 and Cl here on 6. Oh yeah, draw a table with reactant on the one side and then product on one side. Now, once I balance this out, if I distribute this 2 to the iron, we have 2 irons on this side. So to balance it out on the reactant, we just have to add 2 as the coefficient for the iron to balance it out, leaving us with iron as 2. So our balanced equation is 2Fe plus 3Cl2 is produce 2FeCl3. Okay. Now let's use the same approach for question number 2. Look at the subscript. Actually, first, draw the line of reactant and product. So we have Fe and oxygen, Fe and oxygen. Subscript. Fe has 1, oxygen has 2, Fe has 2, oxygen has 1. So here it doesn't matter which one you balance out first. I'm just going to balance out iron first. So do you see how on the reactant side there's only 1 iron and the product side there's 2 iron. So on the reaction side, we have to have the coefficient of 2 to balance it out. So we have 2 and 2 here finally. Now, if we look at the oxygen, do you see how there's 2 oxygen here and 1 oxygen there? So to balance this oxygen out, I need to provide a 2 here, leaving us with 2 oxygen and 2 oxygen here. But what we need to be careful here, once I did that, I realized that I changed the amount of iron there is. So instead of 2, there's going to be 4. Now that means I have to change this coefficient here to 4 to match it up. So as you can see, my first tip doesn't always work out, so you have to guess and check. That's what balancing equation is all about, is guess and checking. But you need a first initial push or initial guidance to solve. But here, this is how you will double and check and everything. So our final answer will be 4Fe plus 102 2Fe. Oh, yep. Perfect. Now let's go to the third question. The third question here, do you see how there's a polyatomic ion, SO4? This is, I think, sulfate. My tip is to balance polyatomic ions first. They are usually the more complicated one. So I put RP, we have FeBrH, SO4, FeBrH, SO4. So here, do we see how we have 3 SO4 and 1 SO4 on this side? So on the reactant side, I'm going to write a 3 here, and then a 1 here, so I can keep SO4 3 for now. We might have to change it in the future. So that's it. Now on the reactant side, we have 6 H's. And then on the product side, the only thing we change here is we have 2 Fe's. So the next thing I'm going to balance out is iron. The reason why I balance out iron before hydrogen is because I guess this comes with practice, but anytime I do balancing equation, I always do, if it has like more complicated like elements like this, I usually do hydrogen and oxygen last. So that's another tip, do hydrogen last. So knowing that, we know that there's 2 Fe. So on the reactant side, which compound has iron in it? It's only the first compound. So I'm just going to times it by 2 here. So now the iron is balanced out. Here now we have BrS6. We have 6 Br. Now, do you see how the Br and H are the same? And in the product side, H and Br are together. That means it works out perfectly, saying that we can just add a coefficient of 6 right there, giving us 6 hydrogen and 6 Br. So as you can see here, our equation is balanced. Now going on to our last question. Our last question is a combustion question. You know it's a combustion question is because you have a carbon-hydrogen compound with an oxygen resulting in carbon dioxide and water. Whenever you have this, moving on to our last question. And our last question is a combustion question. And my tip for a combustion question is that our oxygen here will always be an odd number. Okay. It always happens that way because, as you can see here on the product side, without balancing, there's a total of 3 oxygen. As a result, the oxygen on the reactant side will always be an odd number. And also, the way you know if it's a combustion question is on the reactant side, there's going to be a carbon-hydrogen compound combined with an oxygen, producing carbon dioxide and water. So whenever you see a product as carbon dioxide and water, you should automatically think, or your mind should automatically think that this is a combustion reaction. So knowing that, my tip for you in balancing this, let's see, try and balancing the carbon first. So like my tip in question number 3, I balance the oxygen and hydrogen last. So if I balance the carbon first, do you see how there's 2 carbon on the other side and 1 carbon on the product? So that means our product side must have 2 carbon. So it'd be 2, and I'm just gonna put this as 1 here to keep carbon balance. Now, on the reactant side, we have 4 hydrogen. That means to balance the water on the other side, we need to times it by 2 to create 4 hydrogen. So 4, 4. So next step is to add the oxygen on both sides. So distribute the 2 here. So it'll be oxygen will be have 4 in this atom, and there'll be 2 oxygen in water. So totaling with 6 oxygen. Now on the other side is O2. So to get O2 to 6, we need to make the coefficient 3. So when you do 3 times 2 equals 6. So our equation balance out like this. And on that fact, let me for some reason, okay, yeah. And another quick tip, actually there are cases where the oxygen on the reactant side is even numbers, okay? But most of the time, okay, it's usually odd number. Because these are like the tricky question, and tricky question always have like odd number in it. So that's my tip. Sorry for giving that false assumption there, but there you go.